Hi guys, we'll be starting shortly. I just have some like technical issues on my end, but yeah, we'll start soon.
Okay, so we're gonna start now. Oh wait, is there an echo?
You're muted. You're muted.
Sorry about that. Can you guys hear me now?
Yes, but you're muted again.
Okay, so I think you guys should be able to hear me. Yeah, I'm talking from my other device, and then yeah, I'll just breeze through the first 10 questions, and then we can move on to the harder ones. So the first question, what is the value of 3 plus 1 over 3 plus 1 over 3 plus 1 over 3? So first, if we look at this bottom left fraction, we can expand these two to make 10 over 3. And then it's 1 over 10 over 3, right, like this, which gives us 3 over 10. And then we have 3 plus 3 over 10, multiply 3 by 10 to give us 30. 30 plus 3 is equal to 33 over 10. So then we move the denominator to the top. So we move the 10 up here, giving us 10 over 33, 3 plus that, and we multiply 3 by 33, giving us 99 plus 10, which is 109 over 33, which gives us the correct answer of D. Let me know if you have any questions, if you're like not following or anything. So then the second one, Mike cycled 15 laps in 57 minutes. Assume he cycled at a constant speed throughout. Approximately how many laps did he complete in the first 27 minutes? So what we can do, his speed per minute is 15 laps per minute, 15 over 57 laps per minute, because he did like 15 laps in 57 minutes, right? So this is how many laps he completes every minute, and we multiply this by 27 minutes, which gives us 405 over 57, which is roughly equal to 7, which is our answer choice. We can plug this in and check this because 57 times 7 is 399, I believe, which is the closest to 405. Our next biggest answer, 9, gives us around 500, which is way bigger. So that's how we know it's approximately 7. Then we can move on to number 3, if nobody has any questions. The sum of 3 numbers, A, B, and C, is 96. A is 6C, or the first number is 6 times the third one. The third number is 40 less than the second number. What is the absolute value of the difference between the first and second numbers? So if A plus B plus C equals 96, A equals 6C, C equals B minus 40, we're looking to solve A minus B, right? So what we can do, we can just substitute these values in, giving us our first equation. We can change it to, we can put everything in terms of B because A can be expressed in terms of C and C can be expressed in terms of B. So we have plus B plus C, which is B minus 40. And then A is 6C. So 6 times B minus 40, which is equal to 6B minus 240 plus B minus 40, which is equal to 8B minus 280. AB minus 280 is equal to 96. So B is equal to 280 plus 96 over 8, which should be equal to, let's see, 376 over 8, which is equal to, let's see, 47. C is equal to B minus 40. So C equals 7. A equals 6 times C, which is 42. So the absolute value of the difference is 47 minus 42, which is 5. Okay. If nobody has any questions so far, we can move on to problem 4. Now this one, I know a lot of people messed up on because it's kind of like, it's not really a hard problem, but it's a little bit tricky. So yeah, we can like try to go through this and make it as clear as possible. Tell me if like you have any questions, especially on this one, because it could be a bit confusing. So we want to match up the fuel efficiency in liters. So we have Y liters per 100 kilometers is equal to X miles per gallon. But the thing is, distance corresponds to distance and like fuel corresponds to fuel. So we actually have to flip it. Instead of X miles per gallon, every gallon you get X mileage. The same way for every liter, you have 100 kilometers. So here we really just have to solve for Y. So what we can do, first of all, 100 kilometers, we're given that 1 kilometer is equal to M miles. So we replace 100 km with 100 M. Okay, actually, wait, sorry. 100 km. So this is equal to, let's see, where should I write this? This is equal to Y over 100 M miles. And then we multiply this 100 M on each side to isolate Y, giving us Y equals 1 gallon times 100 M over X. Now we also want this in terms of liters instead of gallons, right? 1 gallon is equal to L liters. So we can replace this 1 gallon with liters. So Y is equal to L times 100 M over X, which when rearranged gives us E. So let me know if you have any questions. But yeah, that's number 4, which challenged a lot of people. Number 5, square ABCD has side length 1. Points P, Q, R, and S each lie on the side of ABCD such that this shape right here, hopefully you can tell, A, P, Q, C, R, S creates a convex hexagon with side length S. So it's like every single equilateral hexagon. So every single side length is the same. So this one's S, 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 S. And we also have that it's a unit square. So this side length right here is going to be S, 1 minus S. Same with this one, 1 minus S. And since it's a square, this is 90 degrees. So we can use Pythagorean's theorem to give us 1 minus S root 2 is equal to S, right? Or in other words, 1 minus S squared plus 1 minus S squared equals S squared, but that's equivalent to the top thing, so we don't really need that. And then, yeah, so we can solve for S from this, right? 1 minus S equals S over root 2, or let's see, 1 equals, wait, we're solving for S, okay, yeah. So 1 equals S plus S over root 2 equals S plus root 2S over root 2. Actually, no. Let's not do it that way. Let's just factor out S, right? So S times 1 plus 1 over root 2. And then we divide each side by this right term to give us S equals 1 over 1 plus 1 over root 2. And we simplify this 1 over root 2, or actually 1 plus root 2, and we get rid of this, right? Because we basically just move this up here. So root 2 over 1 plus root 2, multiply the denominator and the numerator by the conjugate, which is root 2 minus 1. So that becomes 2 minus root 2 over 1. So that's just our answer, 2 minus root 2, right? Sorry if that was a little hard to understand, but it's basically just like we have a equation right here, 1 minus S root 2 equals S, and then we just solve for S and we get it right here, and then all this other stuff. So all this other stuff is just like moving the radical up. So if you have any questions on that, feel free to ask and I can explain that again, but yeah. So there's 2 ways to solve this problem number 6. There's the normal way, like the straightforward way. So A as a negative number, A minus 1 squared. So we just move from here to here and then use this absolute value equation. So then we have A minus 1 squared, square root of that. So since this right here is a negative number and this square makes it a positive number, and then we square root it, which is still a positive number, then it's going to be the negative of A minus 1, right? So A minus 1 squared, square root of that, when A minus 1 is negative, is equal to, so this thing right here is equal to 1 minus A, right? So then when we subtract this, because don't forget we're subtracting it, not adding it, this makes the expression equal to A minus 2 minus 2 minus 1 plus A, because the double negative cancels out, right? Which gives us A minus 2 minus 1 plus A, which simplifies to 2A minus 3, and the absolute value of that. But A is less than 0, so this is actually a negative number, right? Because a negative number minus another number is going to be negative. So we have to, since this is absolute value, we have to make this entire thing the negative of this because it's a negative number, which gives us 3 minus 2A. So our answer is A. But another way you can do this, you can just plug in any random value of A. Now this is a faster way. Just plug in like A equals -1, right? Then we can like use this and look at the answer choices and find the correct one. For example, so if A is equal to -1, this is -2, -2 squared, square root of that, +2, 2 minus 2. Oops, no, sorry. So a minus 1 minus 2 minus, and then this one is this whole thing. Oops. This a minus 1 is -2. That squared is +4. Square root of that is 2. So it's 1 minus 1 minus 2 minus 2 equals -5. And given a is -1, the only one that works and makes this -5 is a, because this one would be -2, this one would be 1, this one would be this one would be 0, and this one would be 3. Therefore, the answer is a, 3 minus 2a. Let's move on to number 7. The least common multiple of a positive integer n, and 18 is 180. So that's this first one right here, right? And then the second one, the greatest common divisor of n and 45 is 15. So what is the sum of the digits of n? So when we go through this problem, it's kind of just like number theory. So what we do, we can factor 18, right, into 2 times 3 squared, and 180 is 2 squared times 3 squared times 5. So this means if the least common multiple has all of these numbers, and 18 only has these, therefore n must contain 1 5, right? Because this 180 has 5, but 18 doesn't. And it also must contain 2 squared, because 180 contains 2 squared, and 18 doesn't contain 2 squared, right? So the only way the least common multiple contains 2 squared would be if n had 2 squared. And yeah. Now let's move on to what we can get from this bottom part. So n 45 can be factored in 3 squared times 5, and 15 can be factored into 3 times 5, right? So what we know that is that n must have at least 1 3 as well, right? Because GCD, greatest common divisor, 15 is a divisor of n. So n is divisible by 3, and it's divisible by 5. Well, we already have that above. But we also have another condition here, because n and 45 have a GCD of 15. Therefore, n cannot be divisible by 3 squared. Hopefully you guys can see why that is. Oh, also, let me plug in my computer so it doesn't die on me. So hopefully you can see why n cannot have 3 squared, because if n does contain a 3 squared, right? If that means not. If n does contain a 3 squared, then the GCD, as n and 45 are both divisible by 9, then the GCD would also multiply by 3. But we don't do that, so we know that n does not have a 3 squared. Therefore, n must have exactly a 3, a 5, and a 2 squared. So 3 times 5 times 2 squared equals 60, giving us our answer 6. And you can validate this just by going through and checking it, right? Like 6 and 18, the least common multiple is going to be, let's see, 180, because it can't be, 60 is not divisible by 18, 120 is not divisible by 18, only 180 is. And then we can check the GCD, because n is 60 and 45. The biggest common multiple is going to be 15. So yeah, this works. A data set of 6 not distinct positive integers, 1, 7, 5, 2, 5, and x. So the mean of this, so the average, which is just the sum of these as shown right here, divided by the amount of them, which is 6, is equal to, should be equal to one value in the set. So when we simplify this, we get 20 plus x divided by 6 is equal to one of these values. And we can cross out 1 and 2, because when we multiply 1 by 6 and 2 by 6, we get 6 and 12. And we subtract this from, subtract 20 from this, which gives us a negative number, right? So x would be a negative number there. And we know that x can't be negative, because in the conditions it stated that it's a positive integer. So we can try 5, 7, and x. So if the mean is 5, right? 5 times 6, 30. 30 minus 20, that's 10. 7 times 6, 42. 42 minus 20 is 22. And then finally, 6 times x is 6x. Subtract x from each side, giving us 5x. 5x equals 20, so x is equal to 4. So then we add all of these, right, because we want to find the sum of all possible values of x. 10 plus 22 plus 4, 36, which checks up with our answer, or lines up with our answer. Okay, let me know if you have any questions. Sorry if I'm going fast. It's because these first 10 questions during the test, generally you want to breeze through them so that you have more time for later questions. But yeah, let me know if you have like any questions. So this rectangle is partitioned into 5 regions. Each region is to be painted a solid color, red, orange, yellow, green, or blue, so that regions that touch each other have to be painted like different colors. So we can pick any arbitrary rectangle. Let's pick this one right here, right? It can be any of the 5 colors. So we have 5 choices for this one, right? 5 times. And then let's look at this one right here, right? And the reason I choose this one, I don't know, it seems like a special case because it's touching 1, 2, 3, 4. It's touching all 4 other rectangles. So it seems important, right? This one, so far, we've only determined that this one can be any of the 5 colors. This one can be any of the 4 colors that isn't this color, right? So if like this one is orange, for example, then this, if the first one is orange, then the second one can be any of the remaining 4 colors. So it's 5 times 4, because for each of these 5 cases for this one, there are 4 cases for this one. Now, for each of these 4 cases here, then we would also have 3 here. And the reason for that is because this right here is touching 1, 2, and it can't be this one. So let's say this one's orange and this one's like green. So this one only has 3 possibilities: red, orange, or blue, right? So that one has 3 possibilities. This one also has 3, because from what we know, it's only touching this one and this one. It's not making contact with this one. So it can be the same color as that, right? So if this one is red, this one is orange, this one is, I don't know, green, this one can still be green. It just can't be red or orange. So for all of these, for like every case, each one of these, let's see, 20, 60 cases, this one still has 3 cases. So we multiply by another 3. And then once again, this last section is only touching these 2 colors. So we subtract 2 of the 5 possibilities again. So 5 minus 2, 3 again. So 3, 5 times 4 times 3 times 3 times 3 equals to 20 times 27 equals 540. Hopefully that makes sense. Let me know if it doesn't. But yeah, this one's like a counting problem. So yeah, you really just use like multiplicative property there. So then number 10, this is a geometry question. So I'll erase this because maybe it makes it unclear to see. But basically, this is what we are given, right? It's a rectangular index card. These are its 2 diagonals, or this diagonal, and then that one. And then these are also length 1, right? And then we want to find the area of the original index card. So how do we want to approach this? How can we use the data given and get the area? So we can have 2 side lengths, right? A, B, or actually, let's not do that. Let's partition this rectangle, right? Oh, dang, that's not good. Sorry, I'm not an artist. So then this way, this way, this way, this way. So we have a smaller rectangle, right? And both of these are like the same triangle, the same square, because they're both 1 by 1s. So call this one A, call this one B. So we have, using Pythagorean's theorem, right? A squared plus B squared equals 4 root 2 squared, which is equal to 32, right? And then we also have that this whole length right here is B plus 1 plus 2. So B plus 2 squared plus, same thing here, A plus 1, 2. So B plus 2, A plus 2. So B plus 2 squared plus A plus 2 squared is equal to 64, right? And then we can just solve this system of equations. I'll just do that real quick. So this is b squared plus 4b, b squared plus 4b plus 4 plus a squared plus 4a plus 4 equals 64. Subtract a squared plus b squared from this one, right? From this equation 1. Subtract equation 1 from equation 2 to give us 4a plus 4b plus 8 plus 32. Sorry, not subtract, substitute. Plus 32 equals 64. So that gives us 4a plus 4b equals, or we can just, 4a plus 4b equals 32 minus 8 equals 20, 24. So a plus b equals 6. And then this first equation, a squared plus b squared, is the same thing as a plus b squared minus 2ab. We know this when we expand this right here, we get a squared plus b squared plus 2ab. So this is just this plus this. Therefore, this one is equal to this minus this one, right? Let me erase that so it's a little easier on the eyes. So like that, right? So this is equal to, minus 2ab is equal to 32, and a plus b is equal to 6. So 36 minus 2ab equals 32. And then, oh wait, actually, we're solving for the area of the original index card. So we're actually solving for a plus 2 times b plus 2. Sorry. So, if it will let me erase. Okay, that's. I think either half the pencil just died, or just give me 1 second. Okay. Sorry. I think it might, it's out of battery. Okay, then give me 1 second to grab something. Okay, here we go. So 36 minus 2ab. Oh yeah, as I was saying, our goal is to solve for a plus 2 times b plus 2, which is equal to ab plus 2a plus 2b plus 4. And we have 2a plus 2b. This one is just equal to a plus b times 2, so 12 plus 4 plus ab, ab, which is, as I was saying before, ab, as I was saying before, this one is a plus b squared minus 2ab equals 32. A plus b squared, 36. So 32, 36 minus 4. So ab is equal to 2. So plus 2. And then let's see. So our answer is going to be 2 plus 12 plus 4, which is 14 plus 4, 18. Nice. So that works out fine. Yeah, sorry if it's a bit messy now. I don't have, I'm just gonna plug in my Apple Pencil while I use a stylus. Hopefully by the time we move on to harder questions, I can use it again, and it has battery. But for now, it might be a little bit sloppy. So you're gonna have to bear with me on that. But hopefully that made sense. Just let me know if you have any questions. Also, send if you have any questions and you want to like ask in the chat with like a private message or something, send it to the Albert Wu with the camera on, not the one sharing the screen, because yeah, that one I can't really see your messages. So yeah. Let's move on. Okay. If it will let me zoom out. Okay, yeah. Let's move on to number 11. Ted mistakenly wrote 2 to the power of m times 4,000 times 1 over 4,096 as 2 times the m root of 1 over 4,096. So the first thing we want to do here is, oh my god. First thing we want to do here is rewrite 4,096. So rewrite this as 2 to the power of m times square root of 1 over 2 to the 12, right? Oh, geez. Over 2 to the 12, right? Which is equal to 2 to the m times 1 over 2 to the 6, right? And then the second part right here, this is equal to 2 to the, Alexa, stop. Okay, so equal to 2 to the power of 2 times 1 over 2 to the 12 over, right, because we're doing the m root m, which is equal to, let's see, which should be equal to 2 to the power of, let's see, 2 to the power of m. Sorry, let me do this again. It's kind of hard to read my own writing. So 2, oh my god. So 2 to the power of 2 times 1 over 2 to the 12 and the m root of that, so over m, right, which is equal to 2 over 2 to the power of 12 over m equals 2 to the power of 1 minus 12 over m. So now, oh, and this top one is equal to 2 to the power of m minus 6, right? Because when we divide a number by 2 to the 6, it's the same thing as subtracting 6 from the exponent, right? So m minus 6 equals 1 minus 12 over m. So we multiply each side by, let's see, what's it? We want to find the sum of all real numbers m. Okay, so we subtract m, we multiply each side by m, giving us m squared plus 6, m squared minus 6m equals m minus 12. So this is m squared minus 7m plus 12 equals 0. And we can use Vieta's formula to find the sum of m is just negative b, which is in this case going to be negative 7, which is just positive 7, giving us our answer C, 7. So, oh, can you send a link to these questions? Yeah, of course. So they're not like officially released by AOPS, but you can find them on this website right here. Yeah, oops, sorry. So everyone can see them here. This is where you can find the link to the questions, and yeah. On Halloween 31st, on Halloween, 31 children walked into the principal's office. Okay, you guys can probably read it on your own. But yeah, they have kids who tell the truth, kids who lie, kids who alternate, right? So, but then there's actually 4 cases, right? So we have truth tellers, liars, alternators who told the truth on the first one, and alternators who lied on the first one, right? So we can set up a system of equations, and this one's really more of like a logic question, but you can also do it algebraically. So we have children who told the truth. So in this first case of the children who answered yes, who said they're a truth teller, so that would contain truth tellers who say that, along with alternators who lied on the first one. So that would be the second A2. So that's 22 people who said they were truth tellers. Oh, sorry, wait. And also liars also said this, right? Liars are also going to say that they're truth tellers. So that's going to be that plus L equals 22, right? I'll make the L like that so you can tell the difference. Now for the second question, are you an alternator? So the alternators who lied first are now going to tell the truth, right? Because they switch every time. So that would be, they're going to tell the truth and say yes. So alternators who tell the truth, and liars as well, because liars are going to lie and say, yes, they're liars, right, is equal to 15. And then we don't even have to write the third equation. We can just subtract this from the first, giving us truth tellers is equal to 22 minus 15, which is, because these terms cancel out, right? So which is just 7. So we don't even need the third one, which is pretty nice. So let's move on to number 13. Let ABC be a scalene triangle. P is a point that on BC such that AP bisects BA angle BAC. Okay, BAC. Oops. And then the line through B perpendicular to AP intersects the line through A parallel to BC at okay, it's perpendicular. So this is a right angle right here. Now suppose BP is 2 and PC is 3. We're looking for AD, right? So how can we solve this equation? Or solve for AP? Now give me 1 second. Let me see if my Apple Pencil works. Maybe it has enough battery. Okay. Let's see if we can write with this now. Still no. Then we'll keep going with this other stylus. Sorry if it's a little messy, but yeah. So we have that we're looking for AD. So we know that if this is the angle bisector, right? This right here is the angle bisector. This line is the angle bisector, and it's also the perpendicular bisector, right? These are both 90. These are both, the same angle. So this one's also the same angle. And then this is also the same line. So by side angle side, angle side angle congruency, right? Because angle side angle congruency, these two are equal. Therefore, it's an isosceles triangle. That's how we get that this one is X, this one is X, because these are both equal. And we can also call this one Y, right? This remaining part Y. And what do we have? So now we can use angle bisector theorem. And that's just like a theorem that you should memorize for competitions. But angle bisector theorem basically dictates that for any triangle, and you have the angle bisector, the ratio of this one to this one is the same as the ratio of this one to this one, okay? So that tells us that x over x plus y equals 2 over 3. Therefore, x, if we just manipulate this a little, right, we have, let's see, 3x equals 2x plus y. So x is just equal to 2y. So the ratio of x over y is equal to x over y equals 2 over 1. Now, how can we use this to solve for AD, right? So if you notice, they tell us that AD is parallel to BC. So we can use that and get that this angle is equal to this angle, right? Because they're alternate interior angles. And this angle is also equal to this angle because they're vertical angles. So these two triangles are similar, right? So AD over BC is equal to, conveniently, x over y, which is equal to 2 over 1. So AD over 5 equals 2 over 1. So AD is equal to 10. Hopefully that makes sense. I have to run to the bathroom real quick, but I'll be right back. And yeah, we can continue, and let me know if you have any questions. All right, I'm back. Let's continue. Let's see, where is it? Yeah, here we go. So let's continue from here. We were at problem 13, right? So let's move on to question number 14. So how many ways are there to split the integers 1 through 14 into 7 pairs, such that in each pair the greater number is at least 2 times the lesser number? So what we noticed about this question, it would be really hard if we had to consider every single case, right? Like if 1 could be with 2, 3, 4, 5, 6, 7, 8, all the way through 14, but then 2 doesn't have to be with anything if we pick 2, and there's like a bunch of complications, right? But we can actually prove that 1 has to be with a number like 8 through 14, and it can't actually be with any of these 7. So the reason for this is because 8 must be the bigger number in its pair, right? Because 8 times 2 is 16, and 16 is not a part of this list, right? So that means 8. So we can think of it as like 7 pairs of lesser and greater, right? 7 lessers, 7 graders, right? And then these 7 must be the 7 lesser ones, right? Because if any one of these, like 2 is the greater one and it's linked up with 1, right? Then we take one of these graders and then we need another lesser. But then 8 can't be a lesser because 8 times 2, 16 is out of this set. Therefore, these 7 must be the 7 lesser numbers. So 7 must go with 14, right? 6 can go with 13 or 12. 5 can go with 10, 11, or whichever one that's 6 left behind, right? Because if 6 goes with like 13, then 5 can also be 12. So then there's one more, right? Plus 1, I guess. 4 can go with 8, 9, 8 or 9, or it can go with, let's see, this one leaves, this 5 has 3 choices, and it only takes 1. So it's plus 2. And then the 6, oh yeah, so it's just plus 2, right? And then this 3 can be with 6 or 7, and this 4 has 4 choices, but it only takes 1, so it's plus 3 more choices. 2 can be with 4 or 5, and then this 3 has 5 choices, so then it's plus 1. Sorry, and it only takes 1, so then it's plus 4. And then this 1 can be with, oh, sorry, dang, I messed up. 3 can't be with 6 or 7 because these two already have partners because they're lesser numbers. So 3, sorry, it's my Alexa. But so 3 actually has to be with one of these 3 numbers that 4 leaves behind. So 3 only has 3 choices, 2 has 2 choices, and 1 is the last one which is left. So then we have 1 times 2 times 3 times 4 times 3 times 2 times 1, which gives us, let's see, 4, wait, 1, 2, 3, 4, 3, 2, 1. Okay, so 4, 16 times 9, which should just be 144, which is our answer. Tell me if that doesn't make sense or if you have any questions. But yeah, question 15. I don't really like this question, but it's because you kind of have to like spot things, right? So we draw our diagram. We have 7, 24, 20, and 15. Right now, if we connect AC, what do we notice about these numbers? If you see 7 and 24 are like 2 sides of a triangle, your brain should just be like thinking like, oh, like Pythagorean triples, right? 7, 24, and 25. This makes a right angle, and it also satisfies the Pythagorean triples 3, 4, 5 here, 15, 20, 25. So these are both right angles. That checks out because the Pythagorean theorem checks out, and then also Ptolemy's theorem, which in the cyclic quadrilateral, the sum of 2 opposite angles is 360. 180. So these are both 90, and this one's 25. So yeah, that should just kind of like the Pythagorean triples. You kind of just have to memorize that and be able to notice those small things. So what else do we know about a right triangle inside a circle? Or any, we know that the hypotenuse is the diameter of the circle. So given that, this becomes pretty straightforward to do, right? We're solving for the area in the circle, but outside of the quadrilateral, right? So since these are 2 right triangles, we know the area of the quadrilateral, we can do base times height over 2. So 7 times 12, which is just going to be equal to, let's see, that's just going to be equal to 84. 4 plus 150. And we're subtracting this from the area of the whole thing, which is going to be 25 over 2 squared. So 625 over 4 pi minus this. So we have a pi, so 625 plus 84 plus 150 times 4, which is, let's see, 234 times 4, because we're solving for a plus b plus c, right? So, and then c is 4. So that's, what was that, 234? 234 times 4 is 936, I believe, which gives us 940 plus 625, which is 1565, which checks out. So yeah, for this kind of question, which kind of is annoying, but I guess that's just unfortunate. It's just you have to use just memorize Pythagorean triples 3, 4, 5, and 7, 25, 24. So yeah, we get 2 right triangles and then use the diameters. Let's see. Moving on to number 16. So the root of the polynomial of this polynomial, so 3 roots are the height, length, and width of a rectangular box. And a new rectangular box is formed by lengthening the edge of the original box by 2 units, right? So to approach this problem, we could solve for the 3 roots, and then we could just add 2 to them and use that, right? But that might take a while, and that could also be like kind of annoying, right? So another way to approach this problem is using Vieta's formula. So Vieta's formula doesn't just apply to like two quadratic equations. It also applies, let me see if I can connect my pencil. Oops, sorry, wrong app. Hopefully this works. Oh, it's connected. Okay. Connected. Okay, nice. So this works now. So yeah, that's gonna make this a lot easier. So the roots of this polynomial are the height, length, and width of a rectangular box. So we can call the roots A, B, and C, right? So we're looking for, we're looking for A plus 2 times B plus 2 times C plus 2, right? Yeah. And then this is going to be A, B, C. Actually, let's write this over here where we have more space. Equals A, B, C plus 4A plus, A, B, C plus 4A plus 2AB plus, we're just expanding this whole thing, plus 2BC plus, let's see, 4B plus 4C plus 2AC right? We have A, B, 2 plus 8, right? And then we can use Vieta's formula. We have A, B, C is equal to, now I can show you how to prove it. We have, if we take the roots, any polynomial can be rewritten as x minus A, x minus B, x minus C, right? This is equal to this. So we know that x, that the x, right, 10 times this, right? So we know the constant term, 10 times negative A times negative B times negative C. So that's negative 10 ABC is equal to negative 6. Therefore, A, B, C is equal to 6 over 10. And that's how you derive Vieta's formula, using this thing right here, right? So ABC is equal to 6 over 10. And then we also have the x term, which is going to be 10x BC, 10x AB, 10x AC. So that's the x term. So 10 AB plus BC plus AC. So AB plus BC plus AC equals to 29 over 10. And then finally, the x squared term is 10x squared a, 10x squared b plus 10x squared c, negative all of that, right? Because it's negative a. So that gives us a plus b plus c equals 39 over 10. Nice. So then we can rewrite this as ABC. So 6 over 10 plus 4a, 4b, 4c. So that's 4 times a plus b plus c, which is 4 times 39 over 10 plus 2ab, 2bc, 2ac. So plus 2 times ab plus bc plus ac, right? So 2 times 29 over 10 plus 80 over 10, which when we expand all of this out gives us, let's see, 6 plus 156, right? Plus, is that 156? Yeah. Plus 58 plus 80 over 10, of course, which is equal to, let's see, 166 plus 58. So, and then plus 80, should be 300. So equals 30, which is our final answer. And I'm going to make this smaller so I have room for the next problem. But yeah, let me know if you have any questions. And oh geez, let me do that. Wait. Okay. Oh, what the? Okay, whatever. I'll just leave it as is then. Hopefully you got all of that, so you don't need this anymore. But yeah, I'll just erase it. If you want me to redo it, I can, but yeah, I need space for the next question. So yeah. Let's move on to number 17, right? This one could take a while and it's easy to make like a silly mistake on. So yeah, 0 times ABC. So that is 0 point this thing, which is equivalent to 100 A plus 10 B plus C equals third times A over 9 plus B over 9 plus C over 9. If any of you guys need me to explain why this is, I can do that. Actually, yeah, I might as well do that right now. So for 0 point A, B, C, if we call this R, then 1000 R equals ABC point ABC, and repeat, and it goes in for infinity. So then we subtract this one from this one, 999 R equals ABC. So R equals ABC over 999 equals, since these are like digit values, right? So it's 100 A plus 10 B plus C over 999. And then we just do the same thing for these three terms right here, and that's how we get these values. So from here, okay, so from here, what we do is we can, yeah, just multiply everything by 27, I guess. I think that's the best way. So 100 100A. Actually, let's just, yeah. 100A plus 10B plus C over 999 over 27, which should just be over 37 equals A plus B plus C. So then that means A plus 10B plus C equals 37A plus 37B plus 37C. So 63A equals 36B plus sorry, not 36B plus 27B plus 36C, right? So from here we get that 7A, because we can divide each side by 9. 7A equals 3B plus 4C. Now from here it's easy to just like assume that it's that A equals B equals C, and that does give us 9 solutions, right? That gives us 9 solutions where it's just 1, 2, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, and so on, right? But there's also more solutions than that, because when we look at this, for each value of BC, we can increase, like for like 666, for example, we can, or like 777. What's one that works? Yeah, 555. 5. If we increase this one by 4 and decrease this one by 3, right, giving us 5. Wait, yeah, 5, 9, 2, right? This also works, I believe. Yeah, because we're adding 4 to this one and subtracting 3 from this one. So that cancels out because 3 times 4 is 12. Negative 3 times 4 is negative 12. So that cancels out, which still gives us 5 times 7, 35. And you can confirm this. 9 times 3, 27, plus 8 is equal to 35. So we can add 4 and subtract 3, or we can subtract 4 and add 3. So that gives us 2 new solutions, right? 5, 1, 8. So that gives us 2 new solutions if we have 5, 5, 5. And then also if we have 4, 4, 4, we also get 2 new solutions in the form of 4, 8, 1, and we get one new solution there. And then if we have 6, 6, 6, we get, I believe, 6, 2, 9. Hold on. No, that's not right. Is it? I think it is actually. Yeah. Wait, let me just make sure. 9. Oh, wait. Oh, that's dumb of me. Yeah, we can't subtract 4 from here. So then we get one new solution from 4. How did you get 37? Let me see. Oh, I just did 999 divided by, sorry, I didn't see your question earlier. But yeah, I just multiplied each side by 27, right? So that just gives me 999 divided by 27, because we multiplied 27 on each side, right? Does that make sense? Because to get rid of these 3s and these 9s, we multiply by 27, and I can go through the division, but 999 over 27 should be 37. So that's how you get this denominator is 37. Hopefully that makes sense. That should make sense, right? But then, yeah. So then you get new cases from 555, 444, and 666. And we get 9 plus 4 from there. And that gives us 13 cases. Right. So yeah, you have to be careful because I actually messed this question up. I just put 9. Okay. Oh god. Is this? Yeah. Okay. I just put 9 during the competition. I messed this question up. It's super easy to get it wrong, but you have to spot those like you can kind of just brute force it as well, but you just have to spot those like side cases like 5, 9, 2 and such. So yeah. Okay, that's not good. My pen's starting to lose battery again, but that's okay. We'll live. So let's go on to number 18. Let T be the transformation of the coordinate plane that first rotates the plane k degrees counterclockwise around the origin, and then reflects it across the y-axis. So here we can kind of just look at a pattern, right? But oops, we have 1, 0 right here, and then we increase by 1, right? So we don't really have to think of it in a coordinate plane. We can think of it as like a circle, and it's at different points on this circle, right? So first it's at 0 degrees, then it goes to 1, flip it across, so 0, 179, and then to, I have to make room for this question again, sorry. So I'm gonna erase this. Or, yeah. And if you guys have any questions, then ask now, because I gotta erase it so I can make room. But yeah. So 0, then it goes to 179, right? And then it increases by 2, so then it's 181. But then it flips 180, so then it's -1. And then it goes to -1 plus 3, so then it goes to 2, 178, right? And then it's 178 plus what? Plus 4 now, so 182. And then we flip that, gives us -2. And then hopefully you can see the pattern. It goes 179, 178, 177, and -1, -2, -3, and so on and so forth. So we keep doing this until we get all the way back to 0. And then how do we know how many this is going to be? How many moves this takes, right? So we can actually like pair each of these off. 0, 179, 1, -172, 2, something, and then all the way to something and 0. Some number and then 0. And this is going to be 179 minus 0. So that's 180 times 2 because there's 2 numbers, right, in each pair. So it's 360. But it's not 360 moves because 0 is included. And that's not even a move. That's where we start, right? So we actually do from here to here. So it's 360 minus 1, which gives us 359. And that is our answer right here. Now for this question, yeah. Wait. Yeah. For this question, number 19, hold on, let me get some water. 1 second, I'll be right back. All right, I'm back. Let's work on number 19 now. So define L of n is the least common multiple of all the integers from 1 through n inclusive. There is a unique integer h such that, okay, we're looking for h. So what is a reminder when h is divided by 17, right? So for this question, 1 over 1 is equal to L17 over L17, right? 1 over 2 would be, let's see, L of 17 over 2 over L of 17. And then we have the same thing all the way to L of 17 over 17 over L of 17. Does that make sense? Because this is just 1/2, and if 1 is L of 17 over L of 17, so this one's just going to be L of 17 over L of 17 and then over 2, right? And then we just move that over to the top, which gives us a whole thing of 17 L of 17 plus L of 17 over 2 plus ... L of 17 over L of over 17, right? Now from here, what we are looking for is the remainder when h is divided by 17. So L of 17, so we don't really have to worry about this anymore. L of 17, because we're just looking at h, which is the numerator. L of 17 is divisible by 17, right? So this first term is 0 mod 17. This second term, you're only dividing by 2, so it's also 0 mod 17. And you notice every single one of these is going to be 0 mod 17 because it's L of 17. So like 17 times some number times 2 times 3 times blah, 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 divided by 2. There's still going to be a 17 there until you divide by 17 in this last term. So this is the only term we need to worry about, right? So L of 17 over 17, the remainder of this when divided by 17 is what? So for that, we have to solve for L of 17. So that's going to be, let's see, 2 to the power 4 times 3 squared times 5 times 7 times 11 times 13 times 17. And then we're dividing by 17, so we get rid of this, right? Does this make sense? Because that's just the least common multiple of numbers from 1 through 17. So like the biggest factor of 2 in there is 16, which is 2 to the 4. Biggest factor of 3 is 9, so that's 3 squared. Biggest factor of 5, 5, 7, 11, is 13. And we want to find this mod 17. So 2 to the power 4 is 16. That's the same as negative 1 mod 17. This is the same as 9. This one is 5. This one is 7. This one's 11. This one's 13, right? 5 times 7, 35, which is the same thing as 1 mod 17. So we get rid of these, turns it into 1, right? Now let's see, 11 times 13. That is equal to, let's see, 143. 143 over 17. 143 mod 17. Let's see, 17 times 7 is 139. So that's 4 mod 17, right? Oops. 143, which is just equal to 4 mod 17. So then 9 times 4, that gives us 36, which is 2 mod 17, and then negative 2, because, you know, this times 1 is still 36, so it's still 2. And then negative 2, so 2. Negative 2 becomes 15, which should check. Oh, okay. I think I messed up here. Let's go through this one more time. That's my bad. But the logic should be fine. I probably just messed up on arithmetic or something like that. 2 to the power 4 times 3 squared times 5 times 7 times 11 times 13. So this is still 16, which is still negative 1. This 3 is 9. This, sorry. This is 5, 7, 11, 13. 5 times 7, 35, still 1. Let's try this a different way then. Oh, this is 9. 9 times 11, 99. 17 times 4, I guess that's 40 plus 28. So that's, no, 17 times 5, 50 plus 35. That's 85. So 85, 99 minus 85, that's 14. 14 times 13. And 14 is the same as -3. 13 is the same as -4. So -3 times -4, that's positive 12. 12 -1 is -12, which is just 17 minus 12, 5. Okay, there we go. That works. So I must have just messed up on arithmetic on the first time. If this process is unclear, please let me know. Hopefully this makes sense, but basically we're just finding this number mod 17, and that's really all it is. Okay, now let's move on to question number 20. A 4-term sequence is formed by adding each term of a 4-term arithmetic sequence of positive integers to the corresponding term of a 4-term geometric sequence of positive integers. Okay, so we can express the arithmetic sequence as A1, right? A, and then we have A plus D plus D, A plus 2D, A plus 3D. And then the geometric sequence, we have B, BR, BR squared, BR cubed. Hopefully that makes sense. And the sum, so this one plus this one, this one plus this one, this one plus this one, and this one plus this one, are 57, 60, and 91, right? So A plus B equals 57, 57, A plus BR plus D equals 60, and A plus 2D plus BR squared is equal to 91. So these are our 3 equations, 1, 2, 3. Now what we do, we subtract equation 2 from equation 1, right? Which gives us, subtract equation 1 from equation 2, sorry. So B minus BR plus, oops, BR minus B plus D equals 3. And then subtracting 2 from 3 gives us, let's see, BR squared minus BR plus D equals 31. And then we can subtract, wait a second, BR squared minus BR. Okay, yeah, I think that should be BR squared minus BR plus D. Nope, that's wrong. Sorry. So, actually, no, that's right. Yeah. Minus BR plus D equals 31. And then we subtract this one from this one, which gives us BR squared minus 2BR equals 28, sorry. So then B, we can factor this up, right? BR times R minus 2 equals 28. Is that right? BR times R minus 2 equals 28. Yeah, that's correct. So then we can just factor, because we know B and R must both be integers. And 28 is equal to 2 squared times 7, right? Or 4 times 7. So what can B and R be? So if BR is equal to 4, R minus 2 is equal to 7. That doesn't work, right? Because then R has to be equal to 9, and 9 times nothing is equal to 4. So that doesn't work. How about if BR is equal to, let's say R minus 2 is equal to 2, I guess. So R is equal to 4. Yeah, R is equal to 4. And then this one is equal to 2. So then BR is equal to 14. That doesn't work either. Wait a second. Did I do this wrong? Sorry. Let's look for BR. This should be right. Let me just check my work again. This one, BR squared. So, and then plus, wait. Yeah, I think that's correct. Let's see. So BR times R minus 2 is equal to 28. So when we factor this, if R minus 2 is equal to 2, B is, okay, that doesn't work. How about 4 and 7? No, so R has to be not 2. Wait a second, let me redo this. I think I messed up. Sorry. Yeah, that's why you have to be careful on these questions. Because like during the test, if you like mess up a question and it's like one of the later questions, chances are you're not gonna have time to like go back and fix it, you know? So that's that's my bad. But yeah, you gotta be super careful. And I guess at the end, I can go over some like strategy tips, but I don't think we're gonna have time to finish all of these questions because I have to leave at 8, but I'll get through as many as I can, and then I can quickly go through some strategy tips. So let's redo this. A plus B is 57. A plus B R. A plus B R plus D is 60. Let's see. Yeah, equals 60. And then A plus 2D plus BR squared equals 91. So the difference between 1 and 2 is, let's see, is BR minus C plus D equals 3. Difference between 3 and 2 is BR squared minus BR plus D equals 31. So subtract these two gives us BR squared minus 2BR equals 28. Okay, so I didn't mess up. Then where are we looking for? We're looking for the 4th term of this sequence. Okay, so we're looking for BR cubed plus A plus 3D. So we actually have to solve for BR and all of that stuff. Okay. Let's see. So B, oh my god. So BR times R minus 2 is equal to 28. So if R is equal to 7, no, R can't be 7. 28 factors of 28 are 2 squared and 7. Let's see, 2 squared is 4. So if R is equal to 4, then B has to be 7 over 2, 3.5. But let's see, do these have to be integers? I think they have to be integers. So BR, okay. So if this one is equal to 4, then this one has to be equal to 7. So then R has to be 9. That doesn't work. If this one is equal to 14, then this one has to be equal to 2. So then R has to be equal to 4, but then B has to be equal to 7 over 2. That doesn't work either. If this one is equal to 28, then this one is equal to 1, then R is equal to 3. That doesn't work either. All right, I'm kind of stumped. I remember I solved this one in competition, but I think I'm doing something wrong here. If I don't remember wrong. Okay, we're gonna come back to this question because I want to get through as much of this as I can. Someone can, like, if someone realizes what I messed up on, just like point it out to me. Sorry. So this one, octagon joining the vertices of the 4 hexagons, right? We want to find the area of this top shape right here, right? So, yeah. So how can we do that? So if we extend these lines right here, and I already drew it out, these red ones, it actually makes a square, right? Because if you look at any octagon, because this is 1, this is 1, this is 1, this is 1, and it's also like a projection of this square, right? This actually makes a square. And we can prove this because, let's see, each of these have to be perpendicular, right? This one is perpendicular to this one because this one is perpendicular to this one. This one's perpendicular to this one because this one's perpendicular to this one. So each of these are 1. And also, as we can see, this shape is clearly like symmetric. So as we have, these are all 90-degree angles, and the shape is like symmetric because all these hexagons are equal. It actually makes a square, right? So now we just have to solve for the side length of these, of this square, right? And it's kind of, so you can kind of see better, but yeah. When we extend this and we extend this guy and we extend this guy right here, we have, since this is an equilateral hexagon, this one is 120 degrees, right? And if we look at this plane, right, this plane right here, this is a flat surface. So this is 60 degrees because these two add up to 180, right? This one is 120 again. This one is 60. So if this is 60, this is 60. This is also 60. So it's an equilateral triangle. And this one's 1. This one's 1. Therefore, this one's 1 and it's equilateral. This one's also 1. And we can use the same logic on this triangle right here to get that using this is 1, we get this is 1. And as we proved before, this is a right angle. So this is root 2. So for the area of the whole octagon, we have this square, which is 1, 2, 3, 1, 1, 1, 1, 1, 1, 1, 1, 1. So that's 3 times 3, the square, minus each of these small triangles, right? So minus 4 times 1/2 equals 9, minus 2 equals 7, which is our answer. So this question is surprisingly kind of easy if you're able to kind of spot this plane right here and use this triangle, get that it's equilateral. But it's kind of hard to find in competition because, you know, it's kind of hard to notice that you extend these lines, and it's an interesting problem, but it's very niche. So I don't recommend, like, for this question, you might just guess. And we're kind of running out of time. I don't think I'll have enough time to go over problem 22. So sorry I couldn't get through the whole set, but I can go through some quick strategy tips real quick, I guess. So for the AMC 10, if you're taking it to qualify AMY, and like taking it for like USJMO is a whole other thing. For that, you want to just score as many, you want to aim for like as high a score as possible. But if you're just looking to qualify AMY, which I'm assuming most of you are, your goal is to get, if there's a question you don't know how to do, like question 25, question 24, these last 5 questions, 20 through 25, generally just leave them blank. Unless you have a really good guess, guessing isn't worth it. Because, I mean, it's really just like, you can do the math on it, right? the expected value, if it's five choices, so you have a 1 in 5 chance of getting the 6 points. So it's 6 over 5, which is equal to 1.2, right? But then if you leave it blank, the expected value is 1.5, right? Well, it's automatically 1.5. And also the chances of guessing right if you leave all 5 are super low. So in these last 5, it's generally better just to leave it blank and get the 1.5 points rather than going for 6. And then for timing, questions 1 through 10 on the test should be generally pretty easy. You should be able to breeze through them, which each question from like 1 to 10 should take you like 2 minutes max, maybe a minute to 2 minutes, I would say. So for that, that's like roughly the time span. So you should finish like 1 through 10 in like maybe half an hour if I'm being generous, or 20 minutes. And then 10 through 15, these can get pretty hard. They're usually like easier, the 4 core concepts, but they could be at like harder levels, just like more complex stuff. And then some of them might have like tricks, like 1-trick questions, kind of like whichever one it was, like this one, number 15, right? So each of those you can kind of spend more time on, but try not to get too caught up. Like if you're spending 10 minutes on a question, just ask yourself, is this worth it? And if like, can I solve this? And for each question, each of these harder questions, I want you to like kind of think, like if you're doing casework for accounting question, or geometry, if you're doing like a chord bash or something, then ask yourself, oh, how long do I think this is going to take? And if it's going to take like 15 to 20 minutes, it's honestly better just to leave it blank or make an educated guess. And another important thing is on these later questions, like I know for number 24, you get something of the form like 1 plus 5 plus something, choose like 20 times something plus 10 times something. And it's a lot of work to calculate it out. But you know that all of these like later things are divisible by 10. And then your first term is 1 plus 5. So you know it ends in 6. So like for these last questions, chances are you won't be able to solve them because they use like more advanced topics. So either leave them blank or use the answer choice to your advantage. Like just like how we did in, which question was it? Just like how we did in question 6, right? So make sure you look at the answer choices, don't get caught up, and make sure you like pace yourself and like time your questions well. And that's really all there is to say. So yeah, sorry I didn't have time to get through the whole set, but yeah, that's it. Have a nice day. Oh man, I gotta leave.